Hello aliens, I'm Lawton Rushford. I am the representative for team number 25 in section 101, section 11 of engineering 131. Right, our milestone 3 includes need finding, and need finding, the need that we are trying to find is a product that the aliens can use that will purify and sustain their life while here at Purdue. The aliens need water while here on Earth that is a little different than ours, so we must create a product that purifies and distributes water to the aliens so that they can drink it and be safe on Earth. Why is this important? Aliens need this to survive, so we want to make sure that they are given the proper tools and proper water that they need to survive for 9 months on Earth and at Purdue University. A story. Throughout an average alien's day at Purdue, they will have to consume a lot of water. So our goal was to make a solution that would help them to drink the water and also make sure it was purified for them and safe for them to drink. The next thing is almost like an inhaler. It is not portable, it's actually a large scale inhaler which would be able to be pulled down by ropes and force water vapor through the 3 tubes into multiple aliens. So it would be helpful for not only one, but multiple in a dorm room or wherever they're staying while on campus. Yes, you got an inhaler. The next 2 designs are very similar. They include flowing water through almost like a gradient, sort of. They will go down a tube filled with a bunch of filter stones that will take out all the harmful particles and eventually make its way to a nozzle, which will then flow water out of it. And there's not so much pressure as there is just using gravity as a pressurized kind of thing.
One of the ways that we decided to reduce our concepts was with the pros and cons chart. And with this design right here, design number 4, you can see that it can hold a lot of water. It reduces the chloride and fluoride level. It is low cost and it would not take a lot of energy, and with its multiple branches it could support use of multiple users. Some of the cons: because it is a little larger, it's not portable, and you would have to build a bunch to support all these aliens, and they'd have to be set up at different locations. Because designs 5 and 6 are so similar, the pros and cons charts are very similar. As you can see, both of these are very large, and the pros are that they can hold water, a lot of water. They can reduce the chloride and fluoride levels. They can alterate the pH levels of the water. Some of the cons: they are very large, they aren't portable. They could cost lots in energy costs, and they could be very expensive to build.
For the second part of our concept design selection, we did a weighted decision-making chart. We had 4 different criteria, one being, can it provide enough water to the aliens, which we weighted as a 10. The second being, is it easy to use, which we weighted as a 10. And third being, does it purify the water to the alien standard, which we weighted as a 15 because that's absolutely necessary. And what is the space requirement for it, which we weighted as a 5 because it would be nice to have but isn't needed. So for the metrics, we had different things such as, is it easy to turn on and off? What is the temperature of the water? What is the maintainability? Can it provide water to multiple aliens at the same time? What is the purification standard, such as what is the pH, and does it filter out all of the impurities that the aliens can't drink? What is the size of it, and can it be easily transported? So for the metrics, we had the temperature of the purified water. The target would be 4 degrees Celsius, which would be a score of 5, incrementing down by 1 until you get less than 2, which would be a score of 1. Then the second one is it easy to turn on and off, which is a yes-no question. So no would be a score of 1, and yes would be a score of 5. The next one would be maintenance visits per month. If it was 1 maintenance visit per month, then it would be a score of 5, incrementing up by 1. And if it was 5 plus visits per month, then it would be a score of 1. The next is for the number of aliens that it can provide water to at one time. If it was 1 alien, then it would be a score of 1, incrementing up by 1. And if it was 5 plus aliens, it would be a score of 5. The next would be the size of the unit, which was measured in meters cubed. If it was 0 to 1 meters cubed, then it would be a score of 5, and if it incrementing up by 1, if it was 4 plus meters cubed, then it would be a score of 1. The next would be, can it provide a continuous flow of water, purified water to the aliens? This was a yes/no question. If it was no, it was a score of 1, and if it was yes, it was a score of 5. The next would be the pH of the water. If it was the target pH of 3, then it would be a score of 5. If it was 1 or 4, it would be a score of 4. If it was 1 or 5, it would be a score of 3. If it was 6, it would be a score of 2. And if it was 7, it would be a score of 1. The removal of chloride and fluoride in the water, the target was less than 0.4 milligrams per liter, so that would be a score of 5, incrementing up by 0.5, and if it was 0.8 or above, then it would be a score of 1. The next would be, can it be transported? This was a yes/no question. No would be a score of 1, and yes would be a score of 5. Notes of the metrics. Basically, they're used for calculating the unweighted benchmarks of the different criteria that have more than one metric in each category. These are the unweighted and weighted benchmarks for our 8 designs. We have 8 designs listed at the top. The unweighted benchmarks are the raw scores that we calculated, and the weighted benchmarks are those scores multiplied by their weight. And at the end, Design 5 and Design 6 were the ones that had the highest total, followed by Design 4. So we decided to pick Design 6 because of the pros and cons list and the results of the weighted decision-making chart. And the reason we picked 6 was because it purifies water to the alien standards. It can provide water to multiple aliens at the same time. It is relatively inexpensive compared to some of the other designs, and only a few would need to be implemented on the campus in order to sustain and provide water for all of the aliens that are visiting Purdue. And this is the bibliography for our presentation.